Hola, hola. Bueno, vamos a continuar. Uh, uh, we continue because I'm waiting for a call. So I have the phone here, and I have when she calls me. I'm ready. I'm ready. Now, for example, have you guys heard about quantum computing? Ikumi? Well, to begin with, what is computing? Well, computing means you know computing means computing. Well, but actually, the when you think about computing, and I went to school for that, and I was so many years in computing and everything, and actually the it means binary. Oh, hello. Hello, you know what binary means? You know, binary. Binary is one and two. No, one and zero. One and zero. Uno y cero. Because the other system is 10. 10. Uno, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the other system. The, but computers don't work that way. Computers don't go by the way computers work is ones and zeros, right? So one means a pulse of energy. Zero means no energy. But they do permutations uh, very quickly, very rapidly. And they can create, for example, you know, I guess that they had to create. So when zero one zero one zero one zero 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 when that's called a binary system. Are you with me? Are you with me? I don't expect you to be a mathematician, but that's the way. The binary system is one and zero, right? Now, when we went to school, well, I don't know, the new generation, you said we had the 10, 10, 10. And now this is 2. What's the difference between 10 and 2? Here's Mario, you see. And I repeat, 1 is a pulse of energy, electricity. Very small charge, but it means a 1. And when you don't send electricity, that means a 0. It's called the binary system. You understand? I don't know, someone call no, the binary system, that's what it is. That's the binary system. And then you have to learn how to program, boom, everything is 1 and 0. Well, what is a byte, by the way? Or bit? What is a bit? I forgot. I think a bit is one digits. I think. Correct me if I'm wrong. So a bit could be a 1 or a 0. What is a byte? A byte is actually 8. Interestingly, a byte is 8 digits. Are you with me? Can you count my fingers? That's byte. A byte consists. That's computer science. I've studied all my life. So a byte is 8 bits. No, how many fingers? I got too many. What is 8? No idea. A byte consists of 8 bits. That's true. That's fucking true. When I went to school in my life, a byte consists of. How many times I'm gonna explain you what the computer science is all about? Well, now we come into a new generation of computers. And then obviously, well, I'm an avant-garde, as always am, of computer technology. So now we work in what you call quantum. Excuse me? Excuse me? Excuse me? Do you know what quantum is? You know what quantum is? Of course you don't. It's not that difficult. I think quantum is actually a different way to call a quantum of energy means a discrete, a particular. So quantum computing means what is a quantum? Oh, by the way. Oh, I'm sorry. I apologize because we have to get back to what computing, no, what quantum physics is. Quantum mechanics, quantum physics, quantum mechanics. Right. And Niels Bohr's, and I don't know. I can tell you. But you can look at yourself. I don't have to tell you. What is computer mechanics? Excuse me. Oh, no. But this is 19th century, 20th century. No, in the 21st century. You haven't caught up. That's why they're developing quantum computing. But you have to know what quantum physics is. What is quantum physics? Excuse me. Well, that's a very interesting question. Because you have relativity physics, right? Relativity. Are you with me? More or less. un poquito, más o menos. So, what's the difference between quantum physics and relativity physics? Well, when you figure it out, you leave me a note, and we have a conversation about it. Okay, quantum physics versus relativity physics. What's the difference? I don't know. I don't know. It's, I have no idea. But I know who the leaders were. Well, Einstein was obviously the leader of relativity physics. Now, there were other people, Max Planck, for example, and a few others that had different ideas. Physical world, the physical world works, which is and then lately was predominant in 20 we're in 20 21st century, are we? Or 2000 and 21st century, right? What theory predominates right now? You know what they call it? Well, among others, string theory. You heard about string. What does it mean? String theory. Hey, you talk to the physicist. But I don't know what string theory is. And the guy they knew, he died in a wheelchair, Stephen Hawking. And even though he was totally physically incapacitated, his brain was brilliant, absolutely brilliant. And he said many important things. And perhaps we have to learn from him. We have to study him. Stephen Hawking. Carl Sagan also. In addition, simultaneously, I think they were. And Carl Sagan did, in addition with other American scientists, they sent the road in a gold-plated disc. They sent into space with a message to other civilizations. That might be there, they might not be there, and that's absolutely fantastic, extraordinary. That I can think that way. I'm sorry. I'm gonna drink water. So anyway, and that's the way it is. So don't bullshit me. I'm a time physics. Well, and I'm gonna tell you no more tonight. No more tonight. Right, but you know what I wanna do? What I really wanna do is promote people. Go forward, ideas, and boom, whatever you wanna be, you make it. Okay, that's all. That's all. Love you. Bye. See you. Chat yourself.